Good morning, students. Today we are going to see an introduction about Creo Parametric software. This Creo software is developed by the company named PTC, Parametric Technology Corporation from US. Creo Modules. So some of the topics, very important topics, what we are going to cover in Creo software are your Creo solid modeling, assembly design, surface modeling, drafting, and detailing. In Creo solid modeling, we will learn about creating components or parts. In assembly design, we will learn about how to assemble different parts or how to combine different parts together, how to assemble them, how to find out if there are going to be any interferences in the assembly or not. Surface modeling is used for creating complex features, curvatures, models with lots and lots of curvatures. So where there is a complexity in it, we will use all surface tools. Drafting and detailing is the process of converting a solid body to a 2D drawing form, where I can send or create the drawing for manufacturing purpose. It is also helpful for creating exploded view of the assemblies and the bill of materials. Now let us understand the course schedule for Creo. First we will go for an introduction. We will understand what is about the software, its general UI and the user interfaces, the shortcuts, and about the menus. Then we will learn about the purpose of creating a sketch entity in Creo, what are the various dimensions involved, how to give constraints. Then we will learn about part design, where we will learn about how to create base features like extrude, revolve, sweep, etc. to create components. Then we will also learn about engineering features, where we can modify certain features like using your hole, shell, rip. Then we'll look for transformation features, where I can create multiple copies of objects using commands like mirror and pattern. Finally, we will also have a look at advanced part design tools, like how to use your component interface, how to assign materials, how to calculate your mass property, what is mean by family table, how to create a family of components, how to relate dimensions, how to create parameterization, what is mean by UDF, what is mean by inheritance, how to merge references from different components. So once this is done, you will get to know an idea how a part design works. So then we will get into the assembly design. We will assemble parts. Finally, we'll go for drafting, where we will know how to convert a 3D model into a 2D drawing, into a perfect engineering or production. What are the steps involved? How to create different views, how to create annotate, or how to create dimensions. Then finally, we will end up the session with creating complex surface features using surface modeling. Creo, the first version of Creo was initially developed in the year 1983. It is the industry's first parametric 3D modeling software. It was first called as Pro Engineer, which later got evolved as Pro E Wildfire. The first version of Pro E Wildfire was launched in the year 2000. After Pro E Wildfire was a raging success, they launched Creo. They renamed Pro E Engineer as Creo. So in Creo we have different modules. One is called Creo Direct, Creo Parametric, and Creo Simulate. Currently what we are dealing with is Creo Parametric model. which means by using dimensions to create models. Using Creo Direct, it is used for creating freeform models. What are the advantages of Creo? It is a feature-based modeling tool. Anything you want to model, you wanted to create it step by step, feature by feature. That's why it is called as a feature-based modeling. Parametric design means at any point of time you can go for a modification in design. That's why we call it as a parametric 3D modeling software. You can go for changes at any given point in your design. Parent and child relationship. Since every features are built step by step, there exists a relation, something called parent and child relationship. So we will be dealing more about it when we get into the 3D modeling. Associativity means converting 3D into 2D, and any changes that you have made in 3D modeling at the later part in your design can be reflected automatically in your 2D drawing or in your assembly design. It is also going to be the vice versa. Any change done in detailing or in your assembly could be reflected back in your part modeling, which makes it helpful for the user not to go for a manual update once again in the assembly or in the drafting part. That's why associativity is something more like an intralink application between all modules. Thank you.